Hi, very good morning to all. Today we'll be starting our fifth module. So our fifth module will be dealing with fifth and sixth module will be dealing with compressors. Compressors means we'll be dealing with mainly air compressor. Compressor is a device which will compress whatever fluids. Okay, we'll be dealing with the air compressors in the fifth and sixth module. So fifth module we will be dealing with the reciprocating air compressor, which is almost similar to a reciprocating pump. We have to consider the effect of compression only. Okay, and the sixth module will be dealing with the centrifugal compressor. Okay. In the fifth module, we will be dealing in detail with the derivation and the problems, and for the sixth module we will give more weightage to the derivations. Okay, we will start with the definition of compressor. So first of all, we will go through what is a compression. Compression is the process of increasing the pressure of air or water, or not water, or any fluids. Normally water is considered as an uncompressible or incompressible fluid. So we'll be dealing with air or gas, any gas or fluid like that. By reducing its volume, the process of reducing its volume is called compression, and the device used for compression is called compressor. So first we will study what are the different types of compressors available. So we will be dealing with the first one, classification compressor based on the principle of operation. We have a reciprocating and rotary compressor. In the fifth module we will be dealing with reciprocating compressor, and the sixth module we will be dealing with the rotary compressor. And second classification is based on the action, single acting and double acting, which we already discussed while we are studying the reciprocating pump. If the piston we are dealing with only one side of the piston, we will call it as a single acting compressor. If we are dealing with the liquid or fluid on the two sides of the piston, we will be calling it as a double acting compressor. Okay. And based on the number of stages, we will be calling it a single stage and multi-stage. If you are only using one stage of compression, if you are increasing the pressure from 1 bar to 2 bar only, and that's called a single stage compressor in a one stage. If you want to increase the pressure to 1 bar to 10 bar, and the first stage will be converting into 3 bar and second stage will be converting into 10 bar, then it's called a multi-stage compression. Stage by stage we are using the compression. For a single stage compressor, we will be compressing up to 5 bar, and more than 5 bar we will be using a multi-stage compressor. Okay. And next classification is based on the pressure limit. We will be calling it three types of compressor we are having based on the pressure limit. Up to 1 bar we will be calling it as a low pressure compressor, and from 1 bar to 8 bar we will be calling it as a medium pressure compressor, and after 8 bar and more than 8 bar we will be calling it as a high pressure compressor. And according to the capacity of air the compressor is dealing, we will be calling it as a low capacity compressor, medium capacity compressor, and a high capacity compressor. Just note the values of 0.15 meter cube per second. If the compressor is delivering 0.15 meter cube per second, we will be calling it as a low pressure compressor. If it is more than 0.15 meter cube and up to 5 meter cube, we will be calling it as a medium capacity compressor, and if it is delivering more than 5 meter cube per second, we will be calling it as a high capacity compressor. Okay, this is all about the classification of the compressor, and now we'll be dealing with the reciprocating compressor. Again, we have two classification based on the single acting and double acting, and based on the stage we will have a single stage and a multi-stage compressor. Okay, and we have already gone through the indicator diagram of the reciprocating pump while we are studying the reciprocating pump. And if here again we have to go through the indicator diagram of the reciprocating compressor, almost similar to indicator diagram of the reciprocating pump, but if we are dealing with the air will be compressed somewhat. Okay, its volume will be changed. Water will not compress, water cannot be compressed. So while dealing with the air, we have to consider the compression of air also, compression and expansion of air also. Okay, here is a schematic diagram of a reciprocating compressor. Mainly there are two stroke, suction stroke and delivery stroke. As all the workings are similar, will be almost similar to the two stroke. For stroke, we have two valve, inlet valve and the outlet valve. During the suction stroke, inlet valve open and the air will be sucked into the cylinder, and it will reach the bottom dead center. And during the delivery stroke, the suction valve will be closed and delivery valve will be open, and the air will be pushed to the outlet or storage tank. Okay, just note down all the parts. It's almost similar to our AC engines and crank, piston, connection row, suction valve, cylinder, like that. Okay, I'm not going into details. So we'll be dealing with the pressure, volume, and temperature is the third term we are dealing with. In reciprocating pump, we are not dealing with the temperature because we are not dealing with the compression of the liquids. So in air we are dealing with the compression of liquids, so we will be dealing with the change in pressure, change in volume and change in temperature. Okay, so we have to go on through some important terms before going to the reciprocating pump in detail. First one is the suction pressure. We will be denoting it by P1. Second will be delivery pressure or discharge pressure. We will be denoting it by P2. And third one is the compression ratio. This is the ratio between the inlet and outlet pressure. It will be P2 by P1. So denoted by small letter R. And the fourth one is the suction volume V1. How much volume of air is sucked during the suction stroke, that is called the volume of V1. And the fifth one is the displacement volume. How much will be the cylinder is moving while we are taking air during the suction stroke from top dead center to bottom dead center. How much will be the piston is moving? It will be given by the cross section area of the cylinder into stroke length will give the swept volume or stroke volume of the cylinder. And the next term we are dealing with the compressor capacity. How much volume will be handling, that is called compressor capacity. And the second one is the last one is the clearance space or clearance volume. In most of the compressor will be there is a gap between the top dead center and the cylinder cover. So there is a gap between, here you can see that even it is the piston is at the top dead center, there is a gap between the cylinder head and the piston. So this gap is called clearance volume. And if we are dealing with the pressure and volume diagram, we have to mark the clearance volume in the pressure and volume diagram. So I will explain. Normally we will be, while drawing the indicator diagram of the reciprocating pump, we will be dealing with a rectangular shape. Now we will be dealing with the air, so we have to consider the compression also. Okay, so when it's reached the bottom dead center, we will be starting from the bottom dead center. It is start moving towards the top dead center. So initially the outlet valve will be in a compressed position, closed position. After reaching some pressure only, it will be automatically opened. Okay, so initially when the piston moving from the bottom dead center to top dead center, the valve is in the closed position and the air inside the cylinder won't have enough pressure to open the valve. So the pressure, so air inside the cylinder will got compressed, and up to 0.2 the air will get compressed. So volume is decreasing, air is still inside the chamber, the air is not going out from the cylinder. So obviously the pressure will be increased. So we are starting from the pressure P1 and it is increased to point P2. When it reached the point P2, it got enough pressure to open the delivery valve. So due to this pressure, the delivery valve will be opened and the air will be pushed out through the delivery valve. So that is the 2 to 3 process. Okay, still there is some air inside this. It is a compressed air. This is the top dead center. There is some air. It is in the compressed position. When the piston is moving from the top dead center to bottom dead center, initially what happened? The outside air will try to enter, but it is a compressed air, so the inlet valve will be closed. So initially when piston moving from top to bottom, the compressed air will expand and will come back to the normal pressure. So initially we are starting the suction stroke at the point 3 and up to point 4, the air inside the cylinder, that is the compressed air inside the cylinder, get expanded and it reaches the atmospheric pressure, that is the 0.4. When it reaches the atmospheric pressure, the inlet valve will be opened, and after 0.4 a negative pressure is created. Due to the negative pressure, the inlet valve will be opened and the air will be entering into the cylinder. So 4 to 1 the air will be entering into the cylinder and we are reaching the point 1. So this is the two stroke of the reciprocating compressor. So 1 to 2 is the compression, 1 to 2 and 2 to 3 is the compression. Actually 1 to 2 is the compression, 2 to 3 is the delivery, and 3 to 4 is expansion, and 4 to 1 is the suction. So then we have 4 stages in a reciprocating compressor. So this is the compressor with the clearance volume. In the initial stage we will study the compressor without clearance volume and then we'll go to the compressor with the clearance volume. Okay. And we have to know one more term is called clearance ratio. It is a ratio between the swept volume and the clearance volume. Swept volume is the how much the piston is moving from top dead center to bottom dead center. So volume, area of the cylinder into stroke length will gives the clearance volume. And clearance volume can be defined as the distance between the top dead center and the cylinder cover. Normally it will be given in the question as a value, or as it will be a 10% of the total volume, like that it will be given. Okay, so clearance ratio is the ratio between clearance volume and a swept volume. Swept volume is the, you can see this volume VC is marked here and VS is marked here. So VS is the distance between top dead center and bottom dead center in volume. Okay. And the next term we have to go through the volumetric efficiency. It is the suction volume by stroke volume of the cylinder. So this term we have to study before going to the derivation of the reciprocating pump. So in this module we will be giving equal importance to derivation and problems, and for the 60 module we will be giving more importance to the derivations. Okay. So first we will study the work done by a single stage reciprocating compressor without considering the clearance volume. So in the previous case we are considering clearance volume. In this case we are not considering the clearance volume. If the clearance volume is not there, the top dead center will be here. The piston will be touching the cylinder cover. So we will starting from the point 4. That is, when the piston is traveling backwards, the negative pressure is created. So from the point 4 itself, suction stroke will be started, and up to 1 we will have the suction stroke. And from point 1 the piston is starting moving upwards. So the delivery valve will not open after reaching certain pressure. Okay. So up to point 2, the air inside the cylinder will be compressed. Okay. And from point 2 to point 3, the delivery will happen at a high pressure P2. So then reaching the point 3, the piston is at the top dead center. So there is no gap between the piston and the cylinder cover. So there is no air between the piston and the cylinder cover. So we have only 3 stroke. There is no expansion stroke in a reciprocating compressor if we are dealing with without clearance volume. If we are dealing with the clearance volume, the reciprocating compressor will have expansion and compression. And if we are dealing without clearance volume, there is no air between the piston and the cylinder cover. So there won't be any expansion stroke in the indicator diagram. Okay, if you are dealing with the clearance volume, we have expansion stroke, and if you are dealing with without clearance volume, we don't have any expansion stroke. And while considering the compression, we have mainly 3 types we have to study. First, we have to consider the compression as a isothermal compression. The second, we have to consider the compression as a polytropic compression, that is PV raised to N is equal to constant. And the third one we have to consider as a isentropic compression, or PV raised to gamma is equal to constant. The value of gamma is 1.4. Okay, and we have to go through the 3 different derivations for the work done for this process. The work done of this reciprocating compressor will be given by the area under the indicator diagram. So area of the indicator diagram. So we have to calculate the area of the diagram for the 3 different types of process. That is for isothermal, and second one is for polytropic, and third one is for isentropic. So we'll be discussing in detail with the coming classes. Okay, thank you.